Good day, grade 10 learners. I am Teacher Sarah, your guide for this week in learning some things about geometric sequences. From this video, you will learn the following. First, describe a geometric sequence and find its common ratio. Second, differentiate geometric sequence from an arithmetic sequence. And third, find the nth term of a geometric sequence. So, are you excited to learn these new things? Let's get started. Let us consider this number sequence 4, 9, 14, 19, 24, and so on. What can you say about this sequence? Yes, it's an arithmetic sequence. Why? Because it has a common difference of 5. In the previous lessons, you learned that a sequence whose consecutive terms having a common difference is an arithmetic sequence. You also performed finding the nth term and the sum of the first n terms of an arithmetic sequence. Now, you will learn about geometric sequences and the process on how they are generated. A geometric sequence is made by multiplying some value each time. Here, we multiply by 3 each time. Let us start at 2. Multiplied by 3 is 6. Then by 3 is 18. By 3 is 54. And by 3 is 162, and so on. What we multiply by each time is called a common ratio. By definition, a geometric sequence, also called geometric progression, is a number sequence with a common ratio between consecutive terms. A term in a geometric sequence can be found by multiplying the previous one by a non-zero and fixed number called a common ratio. Given a geometric sequence, we can find its common ratio by dividing any term in the sequence by the term that comes before it. Let us study these examples. Find the common ratio of the geometric sequences and give the next term. In number 1, we have 80, 20, 5, and so on. Since the common ratio can be obtained by dividing the term by the number that comes before it, then we can divide 20 by 80, that gives 1/4. We can also divide other consecutive terms to get the common ratio, just like 5 by 20, which gives the same result, that is 1/4. So the common ratio is 1/4, which can be multiplied to 5 to get the next term. So 5 times 1/4 is equal to 5/4. Let's have number 2. The common ratio can be solved when we divide 15 by 3, which gives 5. Then we can also divide 75 by 15, which gives the same result, that is 5. So multiply this 5 to 75 to get the next term, which is 375. For number 3, divide -8 by 2 to get the common ratio, which is -4, or 32 divided by -8, which gives the same result of -4. To get the next term, multiply -128 by -4, that is equal to 512. Let us then try to differentiate a geometric sequence from an arithmetic sequence by completing this table. In this activity, we are going to identify if a sequence is arithmetic, geometric, or neither. To be able to complete this table, all we need is to see if the sequence has a common difference or see if it has a common ratio. Let us start with number 1. We will check if the sequence has a common difference, so we get the difference between any term and the term that comes before it. So let's have negative 2 minus 1 equals negative 3. 4 minus negative 2 equals 6. We can see here that the differences are not the same, so definitely the sequence is not arithmetic. So, what if we will divide any term by the term that precedes it? Let's see. Negative 2 divided by 1 equals negative 2. 4 divided by negative 2 equals negative 2. All right, they have the same ratio of negative 2. But let us try to divide other consecutive terms too. Negative 8 divided by 4 is negative 2. 16 divided by negative 8 is also negative 2. Therefore, the sequence is geometric because the consecutive terms have a common ratio of negative 2. Let's subtract again consecutive terms in this number 2. 8 minus 3 is 5. 13 minus 8 is 5. Obviously, they have a common difference of 5. But let us see if it is true to other consecutive terms. 18 minus 13 gives us 5. 23 minus 18 gives us 5. Therefore, the common difference is 5, and this is an arithmetic sequence. Let's have number 3. 8 minus 4 equals 4. 14 minus 8 equals 6. The differences are not the same, so it's not an arithmetic sequence. Then let's check if there is a common ratio. 8 divided by 4 is equal to 2. Then, what about 14 divided by 8? It is equal to 7 over 4. So we can see here that the sequence has no common ratio, so it's not geometric. Therefore, this sequence is neither geometric nor arithmetic. Great! Now we know that an arithmetic sequence has a common difference while a geometric sequence has a common ratio. We are now ready to find the nth term of a geometric sequence. We will be using the formula a sub n is equal to a sub 1 multiplied to r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, and n is the number of terms. Let us now apply the formula in solving some problems involving geometric sequences. The first example is to find the 10th term of the geometric sequence 24, 12, 6, 3, and so on. Of course, we need to follow the steps in problem solving, so step 1 is to identify the known and unknown facts in the problem. For the known facts, we have a sub 1 equals 24. The common ratio is also given, but we need to determine it by dividing 12 by 24, so r is equal to 1/2. And the number of terms is 10, because there are 10 terms involved. For the unknown, we are going to solve for the 10th term. The second step is to substitute the identified values in the formula. Here, we are going to replace a sub 1 with 24, r with 1/2, and n with 10. After replacing the variables, subtract the exponents. So we have a sub 10 equals 24 times 1/2 raised to 9. Simplify this exponential expression first, because we cannot multiply it directly to 24. So we have now a sub 10 equals 24 times 1 over 512. Multiplying these two numbers The result is 3 over 64. So the 10th term is 3 over 64. Example 2 is focused in finding n, or finding the order or placement of a given term in a geometric sequence. Let's try this. What term is 3328 in the geometric sequence 13, 26, 52, and so on? Let us identify the given values. A sub 1 is 13. A sub n, or the last term, is 3328. R is equal to 2, since it is the value of dividing 26 by 13. The problem indicates that we are going to look for the position or order of 3328 in the given sequence. This order or placement is represented by n. So next is to substitute the given values in the geometric sequence formula. Change a sub 1 to 13, a sub n to 3328, and r to 2. So we have the equation 3328 is equal to 13 times the quantity of 2 raised to n minus 1. Let us now solve the equation. We cannot multiply 13 to this enclosed quantity because they are unlike or different terms. So we divide both sides of the equation by 13, and the resulting equation is 256 is equal to 2 raised to n minus 1, which we call an exponential equation. How are we going to solve this? We need to express 256 in an exponential expression in such a way that its base is the same with the base of the expression on the right side of the equation. The base in the expression 2 raised to n minus 1 is 2. So, how many times are we going to multiply 2 by itself to get 256? 256 in exponential form is 2 raised to 8. The resulting equation then is 2 raised to 8 equals 2 raised to n minus 1. Notice that both expressions have the same base of 2. In here, we will apply the equal powers definition that states 2 powers are equal if and only if their bases are equal and their exponents are equal. So by inspection, we can see that the bases of the expressions are now equal, so we can equate their exponents. The resulting equation then is 8 equals n minus 1. So 8 plus 1 equals n. The value of n is equal to 9. Therefore, 3328 is the 9th term in the geometric sequence. The third example involves solving for the common ratio. Find r in a geometric sequence if the first term is 4 and the 7th term is 2916. The given values are a sub 1, which is 4, a sub 7, which is 2916, and n is 7. We are going to solve for the common ratio r. Let us now replace the variables in the formula with the identified values. We have a sub n, which is 2916, and a sub 1, which is 4, and n, which is 7. Next is to subtract the exponents of r. So we have 2916 is equal to 4 times r raised to 6. Divide both sides of the equation by 4, and the simplified equation is 729 equals r raised to 6. To be able to solve for r, we need to extract the 6th root of the terms on both sides of the equation. The 6th root of 729 is 3, and the 6th root of r raised to 6 is r. Therefore, r is equal to 3. That is now the common ratio of the given sequence. There you have it, grade 10 learners. But before we end this video, it's nice to remember these 3 things. First, a geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by the same constant. Second, the common ratio, r, can be determined by dividing any term in the sequence by the term that precedes it. Third, use the formula a sub n equals a sub 1 multiplied to r raised to n minus 1 when solving for the nth term of geometric sequences. I hope that you learned well today. Thank you for watching. God bless and stay safe. This is Teacher Sarah saying till next time.